Alright, Dean Davison, live weatherblogs.com meteorologist. We're going to explain the anatomy of what occurred yesterday with the severe weather and with the tornadoes that occurred here in North Carolina. Let's take a look at what the surface map looked like. You can see the low pressure system was sitting over the Tennessee Valley. That's important, and I'll tell you why it's important. Okay, we have the winds here with a jet stream coming down across in this particular route. Okay, that's your upper level winds coming in this particular route. It's normal, you know, where the low pressure is, where that jet stream digs. So we're having that happen. So the wind's coming this way around the low, so you're getting that nice south fetch. See where the cold front is located, though. So you're getting the southeast winds come in here. There's a mountain chain here. It's called the Blue Ridge Mountains. And we're gonna go into that when we get a little closer into it. The Blue Ridge Mountains run up and down here. So right there, you're getting the southeast wind run into the Blue Ridge Mountains. As this thing's cranking here to the west, or it's going to the east, so you have behind it, you have winds going from an opposite direction. So when they start colliding together, you're getting, I'll show you to the left here, you're going to have one set of wind in the upper levels with the jet stream going that direction, the low level jet going this direction, and then you're getting the low pressure feeding in at this kind of a route here. What's that going in here? It's causing rotation. With the mountains to the east, when it bumps up against it, it's causing those thunderstorms to get bigger. So you have the rotation plus the thunderstorms along the mountains. That's called Leeside Convergence. And I've been doing studies on Leeside Convergence and explaining how this is getting a part of this. When I show you some of the other maps that I have here, it's pretty intriguing. And I'll show you a radar map here in one moment. So here's our overlay here. I'm not going to pay attention to there. I don't know what's going on here. It automatically pulled some of this out of here. Don't know why I did that. But tornado was in Ellsbergo, which is sitting here in the mountain chain near Hickory. Well, here's Hickory here. What's this right here? Here's your Blue Ridge Mountains. Here's your Blue Ridge. Okay, it's east of the Blue Ridge. So like I said, this is the Blue Ridge mountain chain. Your tornado came up through here. What I tell you, it's on the lee side. Thus the convergence of and the lift occurred there to allow this to occur. Take a look at the still radar image of Geography Level 2 analyst. You really have to see this. Your split shot. This is your South Carolina North Carolina border, and this is the reflectivity pattern, and you have the velocity pattern. We also have observations over through here, Shelby, to the west of Shelby. Winds are coming out of the southeast into this storm. Okay. Remember what I said, there's a boundary down here with the winds coming in this direction. Crashing into this. So we have the south winds coming in, the boundary layer sitting right here with westerly winds coming out in front of it. What you're getting there is some strong rotation. You can see what I'm putting a circle at is your tornado. Okay. Like I said, east of the mountains, you got the convergence. The mountains are back out here. So you have that convergence here, and there's your tornado occurring in your tornado warning. So you have a strong rotation here. If you look at the reflectivity, you really can't tell there was a rotation there. But with this information right here, this is the big information that I needed. It goes into my research, is the southeast flow into this storm ahead of the line and the boundary to the east side of the mountains. That's the Leeside Covergence. So that's a little explanation of how these storms occurred. I'm going to show you some imagery of what it showed. I think it's EF2 tornado. We'll take a look at some video and imagery. Here's some images from the tornadoes going on here. You can see these images of roofs totally demolished, areas totally demolished, people picking up the pieces. It's pretty sad. It's pretty extensive damage. Something that I would say is the EF2, because these are good structures, whole roof being pulled off the structures. extensive damage. This is EF1, EF2 damage easily, and things totally flipped. This is a very close EF2 to me kind of damage. I mean, total area is just demolished here, and I made a warning a couple days ago that there would be some situations that would be likely to get tornadoes, at least isolated tornadoes, and fortunately this occurred. And I'm happy that I made a forecast, and if people were paying attention, it was taken aware of. Lake Hickory, pretty bad damage there. So we'll take a look at. There's a whole house just ripped from the foundation. Let's take a look at a video one of the meteorologists down in South Carolina has described what happened, much like I did.
Here at Severe Weather Center 9, of course, all the talk over the last day has been about these big storms that came through the foothills last evening. Pretty rare to get a tornado to fall in January. I did look back through some of the climate data today, going back to the mid to late 50s. Since then, there have been about 24 tornadoes reported over that time frame in the month of January. And that's been on a 25-year time frame, so you kind of average only one a year, so it is pretty rare. The indications are for right now, we're looking at a damage pattern. These are some of the pictures we grabbed from Chopper 9 Skies in this morning. Trees down in parts of Burke County. Now, when you're looking for a tornado signature from damage, you want to find winds that are damage that kind of shows that winds were spinning around in a circular motion. A lot of that can be seen by which direction the trees are laying. We have trees that are down pointing in this direction, kind of the bottom of the screen up to the right. On the top of the screen, we have trees down in the kind of the right of the screen up to the top left, and other parts of the screen more horizontal, other parts are more vertical. So the trees are kind of all broken and laying down in different directions. That's a telltale sign that you probably had swirling winds. So these are some of the things that the researchers from the National Weather Service are out looking at today to see whether or not it's straight line wind damage or tornado. Now, an example of a straight line wind damage would be this row of trees. This is a pretty interesting shot that we saw this morning. Every tree laying down all in the exact same direction. So you get the idea. It's like a big rolling pin of wind that came down and knocked all these trees over all at once. And you can actually get these two kind of phenomena at the same time. You can have swirling winds from a tornado on other parts of the storm, maybe a distance away from where the tornado struck. You may get a straight line push of wind. And it's basically the same thing. Wind speeds can be very similar. It's kind of the only difference between having a box fan that blows in one direction or an oscillating fan that kind of goes around. So the damage can be very similar. We'll know hopefully later today as we work our way through the next couple of days what type of wind damage did all this destruction.
About the little anatomy and some images from North Carolina. For liveweatherblogs.com, this is meteorologist Dean Davison. You always get some research information out of this because it's become very helpful information. For liveweatherblogs.com, meteorologist Dean Davison. Have a great afternoon.